I like to code. I've been coding for a while now. I've been going to DC Python for like a year and a half, something like that. I love programming languages, which is why I'm doing this talk, and I've been really into this language, Rust, for a while now, actually about a year now. So let's do a quick poll. How many of you are Python developers? All right, that's a good amount, or use Python. How many of you have ever been R or used C? Okay, so you guys know how terrible it is. All right, you're okay. How many of you have heard of Rust? It's a cool new language by Mozilla. Rust, which it's a language that's supposed to be aligned to like a cousin of C++ in the sense that it's a successor to C, even though we acknowledge that C will never leave us, no matter how hard we try. Rust is a safe language. It's memory safe, and it doesn't have a garbage collector, which is pretty cool. It's also concurrent. It's very easy to write concurrent programs given its memory guarantees and how memory works. And it's also extremely fast. The compiler is only a couple of years old, the current version of the compiler written in Rust itself, and it's almost as fast as Clang C++ compilers without a lot of the crazy stuff that C++ does. So a quick hello world, is that terrible to look at? Just
good.
Okay, as long as it's not, I'll find some eye-bleach later.
What's the exclamation point though?
Oh, yes, I'll talk about that in just a second. So print line, it's very happy print line, exclamation point. Well, I mean the hello world, I like to put the exclamation point there, no. So the print line, so in Rust, this is a macro. This is what we define as a compile time macro. It doesn't print at compile time, but the reason why it is a macro is because this takes a format string much like Python format strings. You know, you have the little curly braces and then you say what you're putting in next. Now Rust at compile time, let's say you put in two curly braces, two placeholders, and you put in 3 arguments. At compile time, it'll yell at you. It's cool. You can tell it that you want to give it a float, and you want to have, you can give it format specifiers, and if you give it the wrong type, it'll yell at you at compile time. Whereas in C, you'll get a seg fault. And who wants that? In Rust, you won't get a seg fault. And if you do, there's a compiler error. And that's awesome.
What language is Rust written in?
Rust. The original, it curls all the way down.
You go down far enough.
Yeah, the original compiler was written in OCaml. So the language has a lot of functional roots. And the original creator, who doesn't work on it anymore, he left Mozilla. He's doing cool stuff though. He wanted a language that was really low level and it was really safe. And he didn't want to use C because it's not safe and it's not fun. So a little bit more complicated. If any of you have experience in functional languages and you know what a type class is, that's what this is. You have a struct which defines the data. So let's say we have a point, which I'll be doing this for like the entire talk because it's simple. And Rust is a little bit complicated because when you need Rust, that's why you have this. I'll get into that in a minute. So, and sorry for the slide. You can only fit so much code into a slide, so I had to remove some new lines. So you define the data, and then you define the implementation separately. So you guys know Python. If you don't take self as an argument, it's a constructor. So you can have an origin, which just returns point with x and y 0, or you have new, which takes 2 float 64 values, so doubles, or what they call in C-style languages, and it takes self. The distance, it takes self. So that way it is a method, as we see down here. So that's just the mathematical distance formula. It's nothing crazy. And Rust also has type inference. You can say let b equals point new. You don't need to say point if it's obvious. The only time you really need to tell the compiler what type it is if it's ambiguous. If you have a function that can return more than one type, then that way you need to annotate it. But most of the time you don't need to do that, because Rust is really smart. Okay, so it happens to me too.
On constructors, it's not like Java or C++ or something. You have to have point as the name of the function as a constructor.
No, so there is no special constructor here. It's just another function. This is just a function that's in the point namespace. So, you know, point origin, there's no new point, as I'm saying. You can have a function called new, and that's what the convention is for just the default, or, you know, what you'd expect, or origin is also a constructor. So yeah, you don't need, there's no overloading in Rust, so we can't really do that.
There's no classes, this is it.
There's no classes, you have this, if you program a lot in typed languages like Java or C++, you do a lot of interfaces or abstract classes, and that's what Rust does a ton of. We really like to program against interfaces as opposed to doing inheritance, because inheritance is painful in the long run.
So there's no like private protected.
So everything in Rust is private by default,
Okay,
and you can mark it pub. So I can say pub x :f64, and then that'll be public to anything outside of the current crate that I'm in, which is the unit of compilation is the crate. Because it's Rust, I don't know. Get that. So I mean, as you see here, this is type checked. These are debug prints. So A and B don't have a string implementation. I can just derive debug, which is debug printing. So you don't want to debug print in like production code. I don't know why you would, but a number like a distance in F64, you can just do a regular print. So 1, 2, 3, 1, 2, 3. It checks that in compile time to make sure it's okay, and everyone's happy. Yes.
If I added B in distance, would the compiler crash?
What do you mean?
If I added B in distance, the two variables you have there, if I added them together,
B and distance?
yes, if I add them together, would the
So
compiler
B is a
crash?
point, and you can't add a point to a number.
Right, is that a compiler crash? Or
Yeah, it's type error.
Okay.
Rust is really strongly typed. Rust is type safe, memory safe, whole lot of safe. That's what we like, and we like to give it a compile time, so you'll be really, really mad before, and then when it hits production, you'll be happy, because then it'll compile. Eddie?
The origin function.
Yes.
So it looks like you've got a lambda there, but then you've got point inside of point with curly braces on each side. Can you explain that syntax?
Which line? This line?
Nope, up above. Function. Sorry, origin.
Origin. This?
Yep.
Oh, sorry. So this is a lambda function. You can only fit so much in a slide.
It's a lambda.
So let me show you the bigger. Let me format it a little bit. Rust has its own tool as an online playground, so to speak. So I don't want to do live coding, but I'll do it for you, Eddie. So it's just if you format it correctly, you'll see that it's just so if you don't have a semicolon, then it returns the value. It's like an early return, like in functional languages. I'm all the way. Okay.
But so is that a nested point?
No, so so you can do, this is the way you do like a private constructor sort of. It's a literal for defining a constructor. It's a literal. So I can just say, so here I can just say, instead of point origin, I can say let point equals point x is 3.0, y is 2.0. And then that's that. I can use that instead, but outside of the crate, because crate is the most private unit of compilation that there is in a public setting. So if this is an API, you won't be able to do this unless I mark the struct itself public. So you have a function that does that encapsulates.
And then you export point.
Yes. So if I export it, if I make it public, then you can do this. But generally, in the private creation of the, like so in the creation of the constructor, you'd be using the literal definition of the struct.
And so is that point on number 7? Is that on line 7? Is that actually
This one? Oh, so this is saying there's so much. Yeah. Rust is right where drifted just a little bit. So this is just saying define a point in the same way that you do like a C struct, I guess.
right? What's the point on line 7?
This is the return type.
That's
So
the
it's
return type.
fun, name of function, argument list, arrow, return type.
And it can't.
Wait, so the return type's out front there, but it's
You have to repeat it here. Is that
after
what's
every-
confusing you?
but so like line 3 and 4, so the return type is after.
Those aren't return types.
No?
Those are just types.
Like compare to line 14, where the type of distance is those arguments arrow F64. So it takes those arguments, returns as float 64.
Yeah, double. It's easier to know F64 than double.
Or
because you
it
had to
takes
do
nothing,
double in
returns
your
a
head,
point.
Whereas F64 is, oh, okay, it's 8 bytes.
That's
So
nasty.
why can't it figure out?
It does look kind of nasty. I was thinking.
That is what?
Why can't it infer that it's returning a point?
Because Rust doesn't have global type inference like Haskell. So in Haskell, you don't need to say type like ever. But in Rust, we want code to be maintainable. So we say local values, so let binded values. You don't need to do the type. You don't need to say the type if it can be figured out. But for global things like functions, you need to declare the types.
So you always,
Every single function you need to say what type is being returned, unless it's like a generic like T. You say generic T. I don't talk about it here because we'll be doing C interfaces and C doesn't have generics.
So are let's immutable?
Let's immutable by default. Yes, thank you. You can say let mute, which is that's caps. Let mute to make it mutable, and that's better than var. Just really quick. Sorry, everybody hates this because let takes a pattern, not a name. So you can say let. Oh god, what am I doing? And then you can say a tuple, for example, mute a b equals 3 5. So A is mutable and B is not. So it's strictly better to not use var because Rust is awesome. Art?
Yeah, since, does that mean you don't have to actually specify the type of A on line 20?
I do not. I was just showing you an example of specifying the type. I can take this off in the compile. Actually, I can just show you what this does. How about that? It'll actually give me yell at me for a moment, saying it'll say A doesn't have to be mute. So it'll tell you, hey, this doesn't need to be mute. You can just say, nah. Okay, let me take that out, and it'll compile, and it actually tells you the distance between this point and this point is 3.64. You can do the math, it's there. That's, yeah, floats are different in Rust. Haha. No. We use the same libc as everyone else.
Is the power function more costly than multiplying two numbers?
Oh, I just didn't feel like writing the thing twice because like that's some level of Control C, Control V that I don't want. I did it, but then it got all the way here on the slide actually, and I was like, maybe I'll just look for the POW function. So that's.
But do you know which one?
That's a job for the optimizer. The optimizer will probably be like, oh, that can just be done at compile time, even if it knows these values. You know, the optimizer does crazy. It's LLVM. This isn't a homegrown optimizer. This is LLVM. It's insane. Apple millions of dollars, or a lot of money has gone into this, and Rust just piggybacks it. It's awesome. It's super fast. Next slide. Okay. So, oh God, what did I do? Everything exploded. Sorry. It just went blank. Well, that's sad. Sorry. I haven't done a talk yet. Can you see it at least? Okay. It's still black.
So it says, I just quickly read something, it says it's kind of like a system programming language.
Yes. So that's the talk is for. I don't know why.